Okay, let's just review the system here. So recently had a little incident with the Chinese charge controller that we had previously fitted that has died. So you see I've actually replaced that with a little bit nicer arrangement there where I've actually got a proper heatsink on the Schottky diode there, and yeah, so we're now using this alternative battery thing. You may remember from the video a while back, I actually did think this one was nicer and I should probably use it, but the other one was already there, so I went with that. I've actually redesigned this board about 5 times, and I do actually have a new board to go in here, but and you can see one limitation here is that it was a very bad design when I initially did this thing, and I overcooked that trace. It still works though. That trace is far too small for charging. But as it turns out, the new charging strategy will actually be that we don't try to control it directly. Rather, we control the power to the charger. Which seems a more sensible approach anyway. And you can see there's very little on that circuit. I mean, in fact, I think I'm missing. Yeah, so on the new design, obviously, there's. I think this was my very first board actually I got back from the manufacturer, and this current shunt we're actually not. We don't even use it anyway, even though we've got control. We've got the control circuitry there. It's never actually plugged it in because it's all well controlled by that and by the current control on the booster itself. So overall, the system is actually working pretty well now, and just to prevent any complications with the household system. So you might remember these cables that go back through the wall and back into the, you can't see it there, but anyway, goes through the wall back into the Fronius on the outside. I thought just for the purpose of the experiment, I got this small Growatt 15K inverter just to help keep control. Now it does have Wi-Fi and everything in there, so there's nothing wrong with this particular unit. In general terms, we could safely run the whole system on this, no problem. This is a 1500 watt booster and it's a 1500 watt inverter, but given we're running at such a low voltage, we're still running at 12 volts. Again, that's purely because the logic control, the only one we've got is just off the shelf, the 12 volt one there. So so I do actually have ESP32 microcontroller program that can run on any voltage up to 60, but again, finding time to do that is proving a challenge. Now, just again reminding you, this solar / wind charger here is the unit itself is fine, but it is actually for lead acid. You can trick it into working okay with the lithium iron phosphate. So just reminding, remember this is the AGMs we originally bought. So they're 140 amp hour in parallel AGMs. And so the effective usefulness there, you've actually got to halve it. So you would really only get, at a stretch, you'd get 140 out of that 280 ampere hours, but AGM you have to be really conservative, and so I rarely discharge it more than 800. I think on average we're getting about 800 watts onto the house system from that AGM. So even though it's a 280 ampere hour battery, we're really only getting 800 watts. 800 watt hours out of it on a daily basis, whereas these other ones, which I'm not sure you can. Yeah, unfortunately, I've got a bit of tight space up here, but we got these 2 lithium iron phosphate batteries, which I got from Amazon on quite good deal. It was only $800, so $400 each, and they're delivering about 2 kilowatt hours per day to the system. So last night I had a really good outcome. So I had 3 kilowatt hours produced overnight from these off-the-shelf batteries here. So I'm now also using these dedicated LiPo 20 amp chargers. So I'm just charging they're just 12 volt ones, and I'm charging each individual battery at the same time with 12 volts, rather than having to get a 24 volt. Rather than take a step back. So it's still in parallel, so it's still 12 volts. But if we charge each individual battery with 20 amps each, then you get an overall 40 amp charge rate. And this does rely on both those units working relatively well the same. Otherwise, you could get serious, circulation in between the two batteries. But so far, that has worked out very, very nicely. They shut off almost exactly the same time, and have not had any issues there. But I wouldn't rely on this particular situation here without some kind of monitoring, which I'm actually not doing at the moment, but I think that is probably a good plan. So again, for Dr. Rosie's question, can we run their house off vehicle to load from if you just had a small battery? The answer is absolutely yes. It's exactly what we could do here. We're actually not doing it here, so I'm running it just out of the wall. But you can see that given that we're on 240 volts here, and we've got 30 amp on there and 40 amps on here, 70 amps at 240 it's not a huge amount. It's less than that. Yeah, actually, maybe I should do the sums. I'll put it on the screen. So obviously I could just go over here to my Atto 3 if I can get past the other car. So if I go to the Atto 3 and grab out the vehicle to load. Oh, it's pretty dark in here. I'm sorry about that. Grab out the vehicle to load cable. You can see that quite clearly. We've got two power points here, and again, the load we're talking on those two chargers is not huge, and the Atto 3 would definitely take that no problem, considering you could actually charge another Atto 3 with the vehicle to load charger. Not recommended, but I have seen it done on some channels where where the battery has run out on the Atto 3, in fact deliberately, and they've used the vehicle load for another Atto 3 to charge the big battery on the flat Atto 3. So sure, so we could take that cable, come around here, go to the power, plug into there, which is the way that vehicle to load works. So you just plug into the normal socket there. Should I do it? I suppose we should. And then plug in those three chargers, and we'd be charging vehicle to load. And then at the end of the day, you could then use the famous DeLorean, the boosted power system, to take that battery power and feed it back in through your existing inverter. So theoretically all possible. Now, where was I going with that? Sorry, I'm talking around in circles here. So just mentioning that solar charger again, I'm not using it that much, mainly because during the day now with during summer, there's plenty of excess during the day that I can just turn these on in the morning, and the large BYD battery bank that I have, the 16K battery bank that I have on the other part of the building, that copes with any temporary low power generation periods, and I charge these batteries up. The AGMs pretty much take all day, because they when they get to absorption, they actually hang around in absorption all for a long time. But the lithium iron phosphates with the 40 amp charger, those are charged in 3 or 4 hours. So even at the fairly low rate, that fairly low rate. So Dr. Rosie, that's the answer to your question. Absolutely, you can definitely do vehicle to load at home. there's better ways, but there you have it.